What inspired me to accept this position was in any field, any career, you want to grow in what you do, and I thought this was a great opportunity for me to grow. This facility is a state-of-the-art facility, has the latest technology, and you always want to be involved in something that has the potential to really grow into something big.
Tulare Lake Compost is located in the Central Valley, 7 miles southeast of Kettleman City, near the intersection of I-5 and Highway 41. This state-of-the-art facility was originally conceived of in 2001 and is slated to start up by the end of this year. The challenges of bringing this project to fruition include difficult soil conditions, determining appropriate measures to protect local groundwater, and concerns over impacts to air quality in the southern San Joaquin Valley, already some of the worst in the nation. Through the persistent efforts of Chuck Dowdell's former geotechnical group, air quality and monitoring, air, water, and composting permits were successfully negotiated. Construction of the facility spanned from 2005, with the construction of the paved access road on the 23rd Avenue alignment through 2015, with completion of Phase 1 facilities, which include composting capacity for 100,000 wet tons a year and infrastructure to support up to 300,000 wet tons a year. As a 25-year veteran of the composting industry, I moved my family from Delaware to answer the call to be the superintendent of Tulare Lake Compost. I see vast potential to run a commercially competitive operation that produces high-quality compost and generates revenue for the districts. Nonetheless, as a latecomer to the game, I was curious to understand, what was the impetus for building Tulare Lake Compost? How does the facility fit into the district's overall biosolids management plan? How does the design responsibly address environmental concerns? What is the regulatory environment in California in relation to biosolids and in relation to composting in general? What could be an effective strategy to preserve the long-term value to the districts while developing a robust commercial operation that dovetails with the current statewide transition in solid waste management? The video you are about to see will answer some of those questions. To learn about the origin of the project, I spoke to people who were here from the beginning.
The districts had fortunately had the Pointy Hills landfill as kind of the cornerstone of the biosolids management program for quite a number of years. And it was very nice that it was local, and so that between owning it and it being so close to the joint plan, it was very cheap.
One of the benefits of having the Pointy Hills landfill was that we would have the flexibility to send as much biosolids as needed to that particular facility, which we had complete control over. And a couple years ago, that facility was closed, and we had that gap. We have that gap currently.
The concept was to develop an option or options that the district could own and operate, and thereby fully control. The concept for this project developed with the Howe family, who owns and operates Westlake Farms.
Well, in the late 1990s, the financial situation got pretty severe, and various things, and so we slowed way down, and now cotton is, at one time California had 1.2 million acres plus of cotton. Right this year they got 150,000. And so the cotton economy, the values have gone down with the drought. Unless you've got trees, the biggest value you have is the water that you might own or control. And so we've made the economic decision that we can get more value for our resources by selling them than we can using them.
They were very interested in utilizing biosolids. They're kind of very forward-thinking farming operation.
At that time, land spreading of biosolids was the easiest way to dispose of them, and it was totally legal, both through the federal regulations and the state regulations.
There was an interest in them for the exchange being a fair amount of land that we would acquire, that we would lease back to them, that they would continue to operate, and ensure that there was capacity on that land for the compost that we would generate.
As we started the process of becoming permitted to do the biosolids. There was a big furor in Kern County that spilled over into a lot of the adjoining counties, a resistance to biosolids primarily was initiated by the carrot growers in Kern County that early on the sanitation districts, not just Los Angeles County, but Orange County and others, contracted with 2 or 3 middle people to get rid of their biosolids. So then the middleman would contract with somebody to get rid of them, and the record keeping was very poor. And the carrot growers in Kern County got real concerned that they would plant carrots on some ground that biosolids might have been spread on, that then would give their competition economic marketing advantage. And so lawsuits were filed in Kern County, Kings County in 2002 or 3, lost track of time, made the decision that they would no longer allow the land spreading of biosolids. Any permitting activity we were going through stopped. We had the requirement, as part of the close of sale, that we had to have a conditional use permit or have the permits in place to allow the sanitation district to do whatever they wanted. So we were working on getting the permit to land spread when the county said stop, so we stopped. So then the decision was made to compost the biosolids, because compost, land spreading of biosolids-based compost was legal.
We ended up getting the facility fully permitted for 500,000 tons of biosolids a year, with a long-term goal of having a facility that is reliable, under our control, does not have an end date on any of the permits, that we can ramp up to handle additional biosolids if we need to in a relatively short period of time. That was the idea.
Tulare Lake Compost will be that facility that we can manage, that we can control, and we can have that the confidence that it's a facility that'll manage our biosolids appropriately.
Sri Nanapanini is one of the few members of the district staff to have been involved in Tulare Lake Compost from inception through the completion of construction. He served as a geotechnical engineer of record and assisted in the negotiation of the WDR, and he lives now in Vijayawada in southern India, where I was able to speak with him via Skype.
This is a lake bed, it was a former lake bed. We are on the bank of the Tulare Lake. The clay is highly expansive, so we had to stabilize it. We built this facility on highly expansive corrosive soil, and it hasn't been done before. We have 12 inches of clay liner that is below this whole facility. And on top of the 12 inches of clay liner, we have about 16 to 18 inches of lime-treated soil, 3% lime mixed in place. Then we have a soil cement layer that is also up to a maximum of 18 inches above the lime-treated soil. So you have 3 layers, and then on top of that you have asphalt on majority of the developed areas. Since we demonstrated about the condition of water at the site, groundwater at the site, we were allowed to just go with a single liner, which is 12 inches of clay, on-site clay, processed and compacted in place. And the stabilized soil is for constructing the structures. We needed a workable surface for the structures and also to minimize the settlement. Even though we stabilized and we have a pretty good design in place, you are going to see some expansion contraction issues, especially at the interfaces between asphalt and concrete. You need to have a pretty good maintenance program to seal all the cracks. You have almost 50 acres of asphalt, so you have to constantly make sure it is being sealed properly. That way you're cutting off the water from reaching the subgrade below.
Malika Jones, the solids handling engineer at JWPCP, tells us a little bit about how the biosolids loading process takes place.
We have 3 truck loading stations. We use truck loading stations 2 and 3 for normal operations, and truck loading station 1 for standby. The loading processes for each truck loading station is different. For truck loading station 2, the biosolids are conveyed from our store silos to a surge bin, and then discharged into a weigh bin, and then dumped into the truck in one single dump. For truck loading station 3, the biosolids are conveyed from the storage silos, then to a surge bin and continuously discharged into a truck until the desired weight of the biosolids in the truck is reached.
Next stop, Tulare Lake Compost. Here's a view of the facility while driving up 23rd Avenue. As the truck arrives, the driver starts a transaction with his card, weighs his load, and proceeds to the mixing building. We've routed trucks to the south of the site to minimize the impact on operations. Loaded biosolids trucks will enter the mixing building using the high-speed overhead doors. These doors will close automatically behind them to seal in foul air. Here's the view the loader operator will see from the mixing floor. You can see the railing where the trucks will side dump biosolids and the amendment receiving doors. Here we have an exterior view of the amendment doors, through which a loader will dump moistened wood chips. Once loaded, the mobile roto mixer will blend, transport, and discharge the biosolids and wood chip mixture to an open gore windrow. Once the piles are formed, the tarp winder is driven to the active compost field, and the newly formed pile is ready for tarping. The tarp winder has been specially designed by Gore to manipulate their proprietary covers. When properly installed, each Gore cover creates the equivalent of a separate in-vessel composting system. We chose the Gore system for the reduction in emissions that it provides. The districts were concerned that the project be designed to minimize impacts to air quality. Design features to minimize emissions include containment within the mixing building, cleaning of exhaust air with the biofilter, and containment of the composting process under the Gore covers. David Rothbart was instrumental in negotiating the air permit.
What the sanitation districts elected to do is use a positive ASP, a positive aeration system, where we're blowing air at a much lower rate through the piles, and then when it's blowing through the piles in the atmosphere, you're actually putting a Gore-Tex cover over the pile. And this is like a jacket, a Gore-Tex jacket you could buy at REI. And the air's being blown through there, and it's moist air, and what's happening for the control isn't necessarily the jacket, but it's entraining moisture on the inner surface of this jacket. And that moisture barrier is collecting the VOCs in the moisture, and it's dripping back into the pile, allowing it to be degraded. So that's the process that controls the VOCs and also does an excellent job in controlling odors.
The first few years in the composting business for me was very low tech, sort of mom and pop. Composting, outdoor windrow, leaves and grass, small compost turner that we used to tow behind a tractor, and the material, the grass and leaves, would come in plastic bags, which we had to manually slit. So it was a very low-tech operation. And subsequently, the different facilities that I've worked at, technologies have changed to where we are now with the Gore system at Tulare Lake Compost. I am familiar with the Gore system. It's a great system. It works perfectly when you feed it the right recipe. The mix of carbon and nitrogen, the moisture content, having the right amount of biosolids, the right amount of wood chips, gives you a great recipe. And it's that recipe that you really want to start with.
Here's a bird's eye view of the Gore system. The composting process begins at the farthest point, which is called Phase 1. The middle is Phase 2, and the closest will be Phase 3. Phase 1 consists of 36 piles. Each pile is 185 feet long by 25 feet wide by 11 feet high and contains approximately 1,100 cubic yards of mixed biosolids and amendment. The Phase 1 piles are composted for 4 weeks to further reduce pathogens, as well as to achieve vector attraction reduction. The Gore system is managed based on oxygen and temperature. Here we see probes being inserted into the piles. All data is sent back to the SCADA system, which manages the speed of the fans and the flow of oxygen. By the end of Phase 1, you've met PFRP and VAR. The pile is untarped and moved via loader to another location. This allows the pile to be fluffed and aerated before it is retarped to begin the 2-week Phase 2 process. Upon completing Phase 2, the pile is untarped and moved to another location. This process begins what's called Phase 3. Phase 3 is the uncovered curing phase of the composting process. At the end of Phase 3, the pile is broken down and taken to the mobile trommel screen. The trommel screen will consist of 5/8-inch punch plate holes. The drum diameter will be 7 feet wide by 22 feet long. Wood chips larger than 5/8-inch will be recycled back to the mixing building. Compost under 5/8-inch will be sent to Westlake Farms for spreading on fields in need of amending, and also sold to a variety of end market users. Managing water is a big challenge for this site. The MPW system supplies our wash water, water cannon, biofilter media irrigation, and wetting basins. Most of the non-potable water used at the facility will come from this canal. It will be pumped, filtered, and chlorinated before being stored in the reservoir. The raw water pump station draws water from the canal to the filtration system. The line non-potable water reservoir, which accepts water from the filtration system, can hold over 600,000 gallons with 2 feet of freeboard and is connected directly to the MPW wet well. Stormwater is 100% contained on this site. It is collected in basins, like this one, and pumped back to the West Wetting Basin for reuse. No stormwater leaves or enters this facility. The 2 wetting basins will be utilized to mitigate dust and provide adequate moisture to the incoming wood chip amendments. The water will be stored in this wetting basin storage tank. The maintenance building consists of 4 bay doors, a second-floor mezzanine for part storage, and a gantry crane for heavy lifting. It also houses maintenance staff offices and the weather station controls. The weather station plays a big part in site safety. It allows us to track wind direction and speed and make daily operational changes in regards to tarping and untarping schedules. As is true for all district's facilities, employees are key to a successful operation. As Tulare Lake transitioned from construction to operations, local expertise was brought on board. Since the summer of 2014, George Boucher of A1 On-Site, Robert Majeski of AC Electric, and Andrew Paredes of Fisk Electric have stood shoulder to shoulder with Gore staff to assemble the cover winders in 108-degree heat, and responded on a day's notice over the Christmas holiday to insulate small lines from the first freeze. These 3 are currently the most knowledgeable individuals about how this site functions and its maintenance needs. They will back up the district's new hires during startup and are excited to see the facility nearing operation.
The actual idea of just making things better, being able to turn out a better product, even in simple ideas that I can even do in my, like I was saying, the compost pile in the backyard.
I think it's a unique combination of tried and true methods of process control along with some state-of-the-art parts of the facility. I think when it was designed, they took into account the fact that you need a lot of reliability as well as growth for the future. So they really combined a lot of newer technologies with older, more hardened methods.
I have heard about composting, but not using solid waste as a composting agent. I think that's pretty unique in itself, to take biosolids and turn it into something that we can reuse and grow from.
As you can see, we have a state-of-the-art facility. If you know the composting world, it's a dream come true to have a completely paved site. As we learned earlier, the conception of this project came from the need to maintain a cornerstone facility in the district's biosolids management program, which had previously been filled by Puente Hills landfill. In addition, the passage of county regulations restricting the use of biosolids spiked fears that local biosolids management options would soon shrink dramatically, leaving only much higher cost options for our $25 million a year biosolids management program. However, regulatory trends in the past 15 years have not put us in such dire straits. And the district still possesses many more cost-effective options for managing our biosolids. The exciting challenge is, while preserving Tulare Lake compost as a long-term contingency, how to optimize revenue generation from this incredible facility. Dr. Howard Levinson of CalRecycle, who's had a long career in the field of organics management, talks about Tulare Lake compost and how the facility is ideally situated to further California state objectives as a significant player in helping the Central Valley to comply with current and future CalRecycle organics management plans.
You have a huge opportunity here at the facility. You know, I know that, or at least it's my understanding, that you're going to have to start up with using biosolids, and some of that's going to come from the Los Angeles basin, and I can certainly understand that as a ready source and you need to do all the startup. But I think in the Tulare area, the Kings County area, you've got a huge opportunity here to link up with your local cities in the county or surrounding counties to take green waste and food waste that's generated from those areas. You've got an opportunity to link up with the ag sector so that those materials that can't be managed on site at a farm or ag operation can maybe come in as feedstocks to the facility. So you've got huge local opportunities here once the facility is fully running, and you can see what the opportunities are for linking up with local feedstock. So I think Tulare, the compost facility, is just really situated in a great area at a great time. We know that there's going to be lots more collection of these materials, and it's kind of how creative can you be in reaching out to those. Linking in with the local food waste and green waste collection programs and that are going to be ramping up as the mandatory organics recycling starts being implemented next year. One of the issues for anaerobic digestion facilities, as you mentioned, Richard, is that they have a residual that's called digestate. It's one of the ideas that a lot of people are talking about is taking that and using it as a feedstock in a composting operation. So again, I think you're primed for working with those anaerobic digestion facilities as they come online. Perhaps you guys should consider an anaerobic digestion facility at the site at some point, co-locating it. I think it would be a great idea. This is a great opportunity to be making a big impact locally and regionally in the San Joaquin Valley, both in terms of getting these materials into a productive use, working with the ag sector and the landscaping folks on building soil health in the ag sector, using mulch or compost as a water retention and water conservation mechanism. You've got job opportunities here that are local, and then you've got connections with greenhouse gas and the ability to reduce emissions from organic materials.
I have a great deal of experience managing commercial operations that recycle organics, and Dr. Levinson hits the nail on the head. The current trend in regulations for organics management is creating a new private sector market for composting in the state of California. This is an opportunity to generate revenue for the districts. The intangible payoff will be the goodwill built with our San Joaquin Valley neighbors, who will understand the pivotal role we will have played in local organics management. One of the big questions in the composting industry is, how do you market your finished product? We went to the people who know the district biosolids best, the composters who handle it on a day-to-day basis, and who have had great success marketing their finished product.
Customers are farms, alfalfa, barley, hay, sorghum growers in the area. They really like the material to add that nitrogen, phosphorus, potassium, and also get a big savings on the water usage. A large alfalfa farmer in the area who has been surprised himself at what the compost has done. He has saved about 13% in water usage, and he's had about a 12% yield increase in his crops, a variety of different crops as well. He's in a very sandy soil. He's really seen a lot of the great benefits that a biosolids compost can have on the environment. The biggest thing he gets out of it is we're in a regulatory water market. He's regulated by the Mojave Water Agency, and they're getting ramped down at what they can actually use. So an alfalfa pivot might use 900 acre-feet a year, and with our compost he can save almost 100 acre-feet a year, which is a significant amount. He saw the end result and the savings in water and the yield increase immediately. I'd say in the first year they might cut 5 to 7 times on alfalfa. He saw it immediately, and it improves over the years. So over the 3 years, he's seen it get better every year.
Riverside is doing a study right now using several different types of compost, including our compost, which is a biosolids compost. And what they're doing is they're quantifying the water savings capacity of soil that is amended with compost. And so the assumption from literature searches and other studies that's been done around the country and in Europe is that compost can save at least 30% water. So University of California is doing side-by-side comparisons with unamended soils and soils amended with compost, and they're cranking the water back on some of the plots to 30% less water, and then they're measuring yield. So the expectation is that they can quantify that we can save 30% water. What the USCC did is we developed standardization from lab testing, lab protocols, lab methods, and lab reports. And so across the country now, in any state and any community, a compost producer will go to a lab and have a report that looks exactly the same. That protocol then is sent out to landscape architects and other people that would spec compost into their projects, and they begin more and more to trust compost as a part of their projects as opposed to just going to something predictable like a chemical fertilizer. So the USCC has done a fantastic job, I think, in legitimizing a compost market, which used to be kind of a almost hippie industry or a farmer industry. I mean, there was just such an eclectic mix of who would produce compost into something that can be very predictable and very credible.
We're at a particularly interesting time in California with regards to the increased interest and the mandatory diversion of organics from landfills. Now compost is certainly on the upswing. By all means, then the use of compost is certainly being promoted at all regulatory levels, now principally at the state, but also at the federal level as well. This is reflected by the General Order for Compost Facilities that is moving ahead. There's certainly a strong desire to compost in California, and this is particularly driven by ultimately by AB 32 to address greenhouse gas, and then the proper use of compost is an excellent way to achieve carbon sequestration. And of course, we have the historic drought that's underway now, and then we definitely see a reduction in water consumption with the use of compost. We consistently see very positive responses with regards to field crops. Again, our crops are the economic crops that be cotton and wheat and dairy feed. We see, first of all, we see better yields and less water. More specifically than the organic matter, even a light application of 3 to 4 dry tons per acre can improve the soil tilth. We see the improvement of the soil cation exchange capacity. We see an improved soil moisture holding capacity, and the crops we see a better stand. The soil warms up earlier in the spring. We see just a better looking crop. We see a better quality in the harvested portion of the crop. And I guess probably the most interesting that we can definitely see is that where there is a repeated use of compost year after year, we are seeing that a crop can be produced with less water.
You could take anybody's waste in there. You could take other types of waste. Municipalities are looking for big, broad programs. And they could say, yeah, we're going to follow this program, this is what we're going to implement. When in fact, you go and collect each customer one, it's like the old days. I mean, it's old school. And when you start talking to people, you realize there's a lot of waste out there and there's a lot of end users for the compost. the market's there. The Earth Day event was by far the best day I've ever had at Nursery Products. We had 81 fifth graders that came up to the site, and they loved it. They loved the idea of, they liked seeing all the kind of the waste that they would be normally throwing away, and instead we were turning it into a good product. They got to see all the big heavy equipment. They liked getting their hands dirty. They liked kind of participating in making the compost. They were all really excited. And the best was, at the end of the day, a few of the kids said, "Where's the gift shop? We want to buy compost."
The districts place great value on being a good neighbor and developing strong relationships within the community.
The districts for several years now have been providing scholarship funding to the West Hills Community College as part of their Engineering Scholars Program.
We're committed to having facilities that are really good role models for the community in terms of environmental stewardship, taking what others consider a waste and turning it into a beneficial material for seal to use and others as well. With this check, if you could show them, checks for $30,000. So since our partnership began, I think the total has been $135,000 that the Sanitation Districts has donated to the foundation. So with that, on behalf of the directors and our staff, thank you very much for your partnership.
When you're from communities like Huron and Avenel and Lemoore and Hanford, Coalinga, where families are very poor, this really presents students an opportunity to go to college, get a 2-year degree, transfer to a 4-year school in a seamless transition, and save not only a lot of money, but I think make education possible. Frequently I'll have college students tell me, without this scholarship, Francis, I wouldn't be in college. We couldn't do it without the Sanitation District support, and we look forward to a long and fruitful partnership for the college, but mostly for our students, because that's really what it's all about.
As part of that program, we have also started an internship program where only students within the Engineering Scholarship Program are eligible for those positions.
Well, I started just kind of reading manuals and turning them into just some sheets for doing preventive maintenance on the equipment, and now I'm kind of a baby engineer, baby field engineer, junior. And it's good to learn. It's intimidating, for sure. It's a little bit, but it's very exciting to be able to do good work with my head for once. The best way to learn is to stand near smarter people who are smarter than you, so that's helping a little bit. And really just working in an office environment and getting respect as an adult in my field gives you confidence to then go out and actually find a job after I graduate. Before working with you guys, it was pretty daunting after graduating to move on to going from folding sweaters at a retail store to, making engineering drawings to be actual manufacturing processes. So it's good.
A quick story. When my youngest son was in the 3rd grade, I went in as, you do career day. You get dads, moms, whatever, come in as police officers, what have you. So I came in that day as a composter, which I am. And what I brought some food waste, little bags of lettuce, tomatoes, onions, carrots. I bought some leaves, I bought some grass, I bought some wood chips, and I bought a couple bags of our really good screened compost. And I held everything up to the kids and I said, "What is this?" And they said, "Oh, it's a bag of lettuce, carrots and stuff." And I said, this bag of lettuce and carrots is the same as this bag of compost. And you get that, wow, how, what do you mean? It just floors people. So when you're telling people what you do, not only is it amazing to them, but it piques your interest. It keeps you wanting to move forward. It keeps you wanting to do different things. So it's just endless, the possibilities in the composting business. It's so unique. It's so interesting. And the more people understand it, the more people figure out what we're trying to do, it's unbelievable.